Along the bend of the Nile River in modern-day Sudan, the Kingdom of Kush built a massive empire. At its height, the Kushite capital of Meroe boasted more pyramids than all of Egypt combined. The Kushite rulers covered their temple gateways and royal monuments in intricate carvings. These inscriptions recorded military triumphs and sacred rituals, asserting the king's divine right to rule. But the language has no direct living descendants, and unlike Egyptian hieroglyphs, there's no bilingual Rosetta Stone to serve as a translation guide. This linguistic vacuum makes the internal history of this African superpower inaccessible. We are left looking at the monuments of a civilization without knowing how they saw themselves. In 1911, an Egyptologist named Francis Llewellyn Griffith successfully identified the phonetic values of the ancient Kushite alphabet. This created a unique paradox. Modern scholars can read these inscriptions out loud with near-perfect pronunciation, yet the meaning of the words remains a total blank. Phonetic translation without semantic translation creates a dead end. To understand the voices we can now hear, researchers had to build an entirely new method of decipherment from the ground up. The first step was organizing the two scripts, cursive for daily records and hieroglyphic for sacred temples. Meroitic is an alpha syllabary, where a base consonant carries a default a sound. Specific modifiers shift this default to e, I, or o, like spelling Caesar as Kisri. But pronouncing a borrowed word like Caesar is only the start. To move higher, researchers needed to find the rules for building complex, native sentences. If the sounds weren't enough to reveal the meaning, linguists had to look for the language's living relatives to reverse engineer its grammar. Researcher Claude Riley provided the evidence that Meroitic belongs to the Nilo-Saharan language family. Specifically, it is closely related to the modern Nubian languages, spoken today in Sudan and Egypt. Comparing modern Nubian to ancient texts, scholars successfully identified basic pronouns. Ko meant this, and ar meant you. This revealed the verbs. The prefix ye was identified as the first-person subject, translating ye ked to I killed. Finally, the complex suffix ix indicates a plural object. Comparative linguistics transformed Meroitic into a structured, functional language, where we finally identify the actors, the specific actions, and the consequences. But manual translation is agonizingly slow. Decoding a language suffix by suffix takes decades when faced with thousands of unread monuments. This is the modern frontier of computational decipherment, where computer scientists are building the first machine-readable Meroitic corpus. A corpus is a large, digitized dataset of texts used for statistical linguistic analysis. Algorithms use word embeddings to map semantic relationships between unknown Meroitic words, grouping vocabulary together based on statistical proximity. Scientists then cross-reference this data with late Egyptian texts, hunting for cognates, words with a common origin, to see how neighboring cultures described similar events. These computational models scale the decipherment process, identifying grammatical patterns in seconds that would take human scholars a lifetime to map by hand. Combining living African linguistic heritage with machine learning has broken a century-long deadlock. These monuments are no longer silent. The desert skyline of Meroe now represents a civilization whose story we can finally begin to read. By translating royal chronicles and the graffiti left behind by ancient pilgrims, we have gained our first unfiltered look into the Kushite mind. Decoding Meroitic concludes a 2,000-year silence and restores ancient Sudan's original voice, which now speaks for itself for the first time in millennia.